Okay, so you guys did a good job in the game. Okay, so notice that when the function that we integrate is of this form, then we know all cases. When this exponent is odd, or when this exponent is odd, or when both of them are even, or when both of them are odd. Now for this one over here, we only know how to deal with the two cases. One of the case is when the exponent on secant here is even and greater equal to 2, and the other one is when the exponent on tangent here is odd. Okay, what about other cases? For other cases, we don't have any clear-cut guideline. But since we know every case for sine x times cosine x, sine to some power here times cosine to some power over here, we would like to suggest to change this. Okay, so we're going to change this, relate this to sine and cosine. Okay, so we know tangent over here is equal to sine of x over cosine of x. Okay, and we know secant of x is the reciprocal of cosine of x. So you can rewrite them this way. Now by doing this, this is going to relate. It's going to relate back to this one over here. Okay, so it's relate back to sine x cosine x. Okay. Now let's look at this example over here. I'm going to go over two solutions, two different ways to do this. Okay. The first way to do this is to somehow relate this is to sine data and cosine data. So this will be sine data. Well, secant is sine over cosine, so that's sine data over cosine data, and then to the third power. And secant is the reciprocal cosine, so divide by secant is the same as times cosine. So this is equal to this integral that will be sine q theta over cosine square theta. And d theta here. Theta go from 0 to pi over c. Yeah, okay. Now, this one over here, we'll consider this as sine to the third power of theta times cosine to the negative second power of theta, this integral over here. Okay, so this is in the form of this exponent on sine over here is odd. So we put that into this category. Okay, remember for this, what do? We use the save method. So we're going to save one sine data with d data. Okay, so the exponent for the sine data here, this exponent on sine will become even after you save one factor of sine data. Okay, so let's do that. So we'll save sine data with d data. Now this becomes sine of second power now. Data over cosine square theta. Okay. Theta go from 0 to power c. Okay. Now over here you save one factor. So you save one sine data with d data. Then this is going to become negative d cosine data because the derivative cosine data is negative sine data. So you do have a negative sign here in front. So negative d cosine theta is sine theta d theta. Okay. Now this is going to become an integral with respect to cosine theta. So we want to express this all in terms of cosine theta. So use that trig identity. We express sine squared as 1 minus cosine squared. And then the cosine squared theta, you're not going to change it because that's already in terms of cosine theta already. Okay. Now you just need to figure the upper and lower limit for cosine theta. Now you let u to be cosine theta. When theta equals 0, substitute 0 into theta. U is cosine of 0, which is 1. So the lower limit for cosine theta here is 1. When substitute theta here to the power 3, u is equal to cosine power 3, which is 1/2. So the upper limit over here, it is 1/2. So cosine theta go from 1 to 1/2. Okay. Now after this, notice that this is all in terms of cosine theta right here. Okay. Okay. Now there's a negative sign in front. Now remember we use u sub. Okay. So this become 1 minus u squared. We get u to be cosine theta. So over u squared, and this is going to be du. Okay. You go from 1 to 1/2. Now it become a much simpler integral. To deal with this one, we can separate this into two separate integrals. So the first one here is, we're going to write this term by term. So the first one is 1 over u squared, which is u to the negative second power. And then minus u squared over u squared, which is just a 1. And then du, you go from 1 to 1/2. Now, antideuty of u to the negative second power, that is going to be u to the negative first power over negative 1. Remember, you increase this exponent over here, increase by 1 when you find antideuty, right? And then you divide by the exponent. Now, minus antideuty of 1 is u, so u. You go from 1 to 1/2. So this will be negative. Okay, now you can distribute this negative sign inside. So this become 1 over u plus u. You go from 1 to 1/2. Do the calculation that this is going to become 1/2. Now that's the first way to do it. Okay. Another way to do this. Okay. Now you're looking at this integral, the function that you integrate with. Let's think about what is that form. So this one over here is tangent to the third power. You can think about this as secant theta to the negative first power. So you see that the exponent on this tangent theta over here, it is odd. So we're going to do the save method, right? So what do we save? So we're going to save one tangent theta with d theta. So then the exponent on the tangent theta will become even. So the remaining exponent on tangent theta here will be even. Okay. Now this one here is even. Okay. Now only saving a tangent theta with d theta is not enough. We need to save a friend together with this tangent theta. So we need to save secant theta together with the tangent theta. Because this way, this is going to become d of secant theta. Okay. Now, after I save one secant theta with tangent theta, d theta, notice that down here, before was dividing by secant theta. Now you put the secant theta in the numerator. So I need to divide over here by secant square theta. Notice that secant theta over secant square theta, they cancel and give you the secant theta in the denominator here, right? Okay. So So this is a trick. Okay, so even though you don't have any secant data up here, you can still do this trick. As long as at the end you have to divide back this secant data over here. Okay. So the data over here go from 0 to power 3. Now the next integral. Now this becomes d of secant data. So we need to express both of them, all of them, in terms of secant data. So using the identity. So tangent square, it is secant square minus 1. Secant square data, you don't want to change it because it's already in terms of secant data, right? It's already in terms over here. Like this, okay. Now we want this to be u, okay. What happened to, so when data equal to 0, then u is equal to secant data, which is equal to secant of 0. Secant of 0 is 1. So the lower limit is 1. Now what about when data equal to power 3? Then u is equal to secant of power 3, which is going to be 2. So that's equal to 2. So the upper limit here is 2. We let u to be secant data. So this becomes u squared is 1 over u squared, and then the you go from 1 to 2. Over here, we did this use up. Okay, so we did the use up. We have u equal to secant data. Okay, this become, so this time we're going to separate this. So take each term on top here, divide by this denominator. So we get 1 minus u to the negative second power. And then du, you go from 1 to 2. Antiderivative 1 here is u. Antiderivative this is u to the negative first power over negative 1. You go from 1 to 2, which is the sum of u adding 1 over u. You go from 1 to 2. Substitute, that is 2 plus 1/2 minus 1 plus 1. So that's equal to 1/2, which is the same answer that you got from the first solution, first method. Yeah, you see, it was 1/2 from the first solution. Now we also get 1/2 over here. So you can do it. So this problem over here, you can either put this in this category, or you can put this, you can express this in terms of sine data and cosine data, and then that will be under this category over here. Okay, the answer here would be the same or would be equivalent. Okay. Okay. Over here, I have two formulas that are helpful to be remembered. The antiderivative tangent x is ln of absolute value of secant x plus a constant. The most general antiderivative of secant x is ln of absolute value of secant x plus tangent x plus constant. Notice that tangent and secant are always related. So their derivative are related, and also their antiderivative are also related. So tangent here relate to secant this way, antiderivative secant relate to secant and tangent this way. So try to remember this two formulas. Now let's do this problem over here, see if we can make use of this two formula. Okay. So first of all, I'm going to separate this into two separate integral. Okay. So the reciprocal cosine, it is secant. So this is secant x. Sine x over cosine x is tangent x. Okay. Now, according to the formula that we have above, antiderivative secant x is ln of the absolute value of the sum of
secant x and tangent x.
And untitled of tangent x here is ln of absolute value of secant x. And then don't forget to add the constant, that's c. So you can try to differentiate this, see if you get back the same function that you started. Now to summarize it, when the function that we integrate with is of either this form or this form, we have the strategy that we use will be the safe method. And now, and also when the exponent for sine and cosine here are both even, then we use a half angle formula. Okay, safe method or half angle formula. Now this type of integral, notice that this is not just x and x, instead is mx and nx. So when you have this type of integral, either sine times cosine, cosine times cosine, and this inside here will be mx and nx. We'll think about the sum of angle formula and the difference of angle formula. So remember, sine A times cosine B is 1/2 of sine A minus B plus sine of A plus B. So, and this two will be similar. Okay, I remember I used to memorize all those trig formula. Okay, so this one over here is sine of 4x times cosine of 5x, and you're finding the integral of this function here. Think about this as a A and think about this as a B. Okay? So that will be this case here. So we're going to use this formula. So that's equal to the integral of 1/2 sine of, well, what's A minus B? A minus B over here, it is 4x minus 5x. So which is going to be negative x. And then adding sine of A plus B, which is going to be 9x. Now we're integrating this with respect to x. Okay. So this is the 1/2 here is a constant multiple. We take it in front. Also, sine of negative x is negative sine x. And then plus sine of 9x x. Antideuty of negative sine x is cosine x. Antideuty of sine 9x here, it is negative cosine 9x over 9. And this is an indefinite integral, so don't forget to add a constant c. Okay. Now we're done with our lesson. So done section 7.2. Right?